Hey everyone, and welcome to Lecture 1 here at Skip Uni. I am absolutely thrilled to have you here today because we're going to tackle one of the most foundational and honestly incredibly powerful concepts in all of programming. We're talking about object-oriented programming, or OOPs. Now, whether you're completely new to programming and maybe a little intimidated, or you're just looking to really solidify your foundation, don't worry at all. In this explainer, I'm going to break this down so smoothly, it's going to feel like butter. We'll be using a huge, highly relatable real-world case study to make sure these concepts stick with you for good. Okay, let's dive into this because you really need to understand the stakes here. Why are we focusing so heavily on OOPs? Well, if you're stepping into the tech world, I can guarantee there is no technical interview, no competitive programming exam, and zero software engineering screenings where you won't be grilled on this stuff. It's an absolute, non-negotiable necessity. Mastering this doesn't just make you a coder, it literally makes you a software architect. So, here's our roadmap for this explainer. First, we'll look at the shift to OOPs. Then we'll define real-world objects. Next, we'll cover classes and objects. And finally, we'll break down the 4 pillars. Let's get started. All right, let's jump right into Section 1, the shift to OOPs and modular programming. To really appreciate where we are now, we kind of have to understand where we came from, right? Before OOPs became the gold standard, we relied heavily on procedural programming. Think of the classic C language. It was pretty rigid. You'd give it an input, the system would do some calculations, and it'd spit out an output. But as software got more and more complex, developers realized they needed a completely new philosophy. They needed a way to model actual real-world problems, and that's exactly what object-oriented programming brought to the table. Instead of just doing linear calculations, OOPs lets us organize our code by mimicking the real world. It makes our systems highly scalable, super organized, and just so much easier to maintain.
Moving on to Section 2, real-world objects, and we're going to use a food delivery metaphor for this.
So, how exactly do we model the real world? Well, in the OOP's philosophy, literally everything is viewed as an object. If you've studied databases before, you probably know about entities. Objects are exactly the same concept. To make this crystal clear, we're going to use a food delivery app. Let's just call it the Zomato ecosystem to illustrate every single point from here on out. In our app, the restaurant is an object, the delivery agent is an object, and you, the customer, are an object. And every single object is made up of 2 distinct halves. First, you have data. These are your characteristics, your name, your phone number, your address. And second, you have behavior. These are the actual methods or functions you can perform, like adding to your cart, making a payment, or tracking an order. Every single object in programming is just a combination of its data and its behaviors. Which brings us to Section 3, classes and objects, the absolute foundation. This is where the real architecture begins, guys. It's where we shift from theory into actual design. Think of a class as the blueprint, or a map. It's exactly like a cooking recipe. A recipe itself isn't food, right? It just tells you how to make the food. It dictates that a customer should have a name and a phone number. The object, on the other hand, is the actual real-world entity created from that blueprint. It's the actual dish you get to eat. And this brilliantly illustrates how you can write a class just once and then use it to generate millions of unique, real customer objects. And now for our 4th and final section, the 4 pillars explained. So, we have the blueprint and we have the objects. Now we arrive at the most critical stretch of this explainer, the 4 pillars of OOPs. They are encapsulation, inheritance, polymorphism, and abstraction. If you can understand these 4 concepts, you have practically mastered the philosophy of object-oriented programming. Let's kick things off with Pillar 1, encapsulation. In really simple terms, encapsulation is about binding your data and your methods together into a single, secure unit. It's all about hiding the internal state of an object and making sure any interaction happens specifically through predefined methods. I mean, you never want a user to have direct, unrestricted access to your database, right? Let's look at how this works in practice. As a food delivery customer, encapsulation essentially guarantees you can only interact with the app in ways you're actually authorized to. You are absolutely allowed to view your order and make a payment. Those are your permitted methods. But you are strictly blocked from diving into the back end to change a restaurant's menu or artificially boosting their overall rating to 5 stars. Encapsulation wraps this protective shield around the data, ensuring objects only ever interact in very secure, predefined ways. Moving right along to Pillar 2, inheritance. Just like you might inherit genetic traits like eye color or height from your parents, classes in OOPS can inherit properties and behaviors from other classes. This is an absolute game changer for code reusability. Instead of writing entirely new code from scratch every single time, you just take an existing blueprint and build right on top of it. Now, what's really interesting about this slide is how inheritance makes upgrading a system so beautifully simple. Let's say our normal customer decides to upgrade and buy a premium membership, becoming a Zomato Gold customer. The developers don't have to go in and write a brand new user profile from scratch. No way. The Gold customer class simply inherits all the base data from the normal customer, the name, the phone, the address, and then the system just tacks on the new premium behaviors, like free delivery and special discounts. It saves a massive amount of time and keeps the codebase incredibly clean.
Next up is Pillar 3, Polymorphism. Now, the word itself literally translates to many forms. In programming, polymorphism means that a single concept, whether that's a name, an object, or a method, can take on different forms and have multiple unique uses, entirely depending on who or what is triggering it. Consider the track order method. It's literally just one method name written in the code, but see how polymorphism allows it to adapt? When the customer hits track order, the map pops up to show them exactly where their food is. But when the restaurant hits track order, they see if the driver has arrived for pickup. And when the delivery agent taps track order, it gives them GPS directions to the customer's house. It is one single method taking on completely different functional forms based entirely on the object using it. How cool is that? And finally, we arrive at Pillar 4, Abstraction. If encapsulation was all about security, abstraction is all about simplicity. It's the practice of hiding all the chaotic, complex background details of how a system works and presenting the user with only the clean, essential interface they actually need. Think about it like this. When you're hungry, you basically follow 3 simple steps. You open the app, you order a masala dosa, and you make a payment. That's your interface. Behind that simplicity, massive, highly complex API calls are pinging servers all over the place. Payment gateways are encrypting your financial data, and a restaurant kitchen is physically prepping ingredients. But abstraction hides the whole shebang from you. You don't need to know how the API routes data or how the chef chops onions just to eat your dinner. You just press a button and enjoy your food. And there you have it. You now intimately understand the fundamental philosophy of object-oriented programming and its 4 pillars. But, understanding the blueprint is really just step 1. I want to leave you with this provocative thought. We know how this food delivery ecosystem operates conceptually now, but how exactly would you write the syntax to build these actual objects in a language like C++? That is the exact thrilling challenge we're going to tackle in our next explainer, where we take all this theory and execute it in real code. Until then, keep exploring, and I'll catch you in the next one.